Hey guys, so in this video, we're going to go through the example problems, not all of them, but some of them, so you can have a better idea of how to use these formulas here for compound events. Remember, if they're overlapping, we need to subtract out anything they share. And if they're disjoint, that means they share nothing at all. So looking at question 1 here, okay, we can see clearly there's no overlapping. So this is a disjoint. Okay, we're going to have looking at the probability of it being a 10 or a face card is the goal. So I'm going to put that in here. So with this, just be aware that probability of event A is going to be our 10, and then we'll use our face cards for B. Okay, so as we're doing this, first thing, I know it's out of 52 playing cards, so that's my total. I know I'm adding them. And I have no overlapping. So really, I don't have to subtract anything out. There's nothing there. So you don't even have to put that. Okay, when I look at the next parts, so probability of event A. So the 10 cards, I have 1, 2, 3, 4 of those. And then for the probability of event B, I can see I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 of those. And again, there was nothing shared. So there was no A and B overlapping section. All right, so there is no overlap. And then all you're going to do is just add those together. So 4 plus 12 is 16 out of 52, which is about 30.7%. Again, it's up to you. You can either leave as a fraction, you can reduce your fraction, you can write as a percentage. It's completely your choice. Okay, so for the next one, we have a face card or a spade. And again, we can look at our Venn diagram over there to help us out. You can see I'm setting up everything. And I always put with an overlap. I always do a subtraction, even if there is not one. Like we have none in the first one, so it didn't matter. Okay, so again, we have 12 face cards. We have 13 spades. You always have 13 of each. And then we have that overlap. We have this area in the middle, and there's 3 of those that overlap. So we want to subtract out that overlap as we go through this. And then again, just like before, we're simply going to add 12 plus 13 is 25, minus 3 gets us 22 out of 52, or about 42.3%. So again, as we go through this, we want to take note, are things overlapping or not? If they don't overlap, we always have nothing there to subtract. You can put the -0 for no overlap. You don't even have to put anything here, right? I got this whole thing gone since there is no overlapping. It is completely up to you how you look at it. Okay. All right. Next ones are very similar, so I'm not going to go through those. We have our error analysis. Again, similar idea. Thing we want to be aware of is that the error in the first one, a heart or a face card. So you can have face cards that are hearts, king of hearts, queen of hearts, jack of hearts. So you do need to subtract out here. And in this case, they added the doubles instead of subtracting them. Okay, in the next problem. So now we're going to use that formula. We're going to use our overlapping formula here, and I'll write it down so we can look at it. All right, so the probability of A or B equals the probability of A plus the probability of B minus the ands. Okay, so when we look at this, we're going to kind of be aware of a couple things. We have 200 students in a senior class. That's a total. That's important. Then we have 113 are either varsity or honor roll. So that's the or. I know that amount. Okay. Then I have 74 seniors who are varsity. So that could be my A. I have 51 seniors who are on the honor roll. That could be my B events because those are individual events. And we're looking for varsity athletes and on honor roll. So we're looking for the and. We're looking for this component now. Okay, so when I fill in everything, it's all out of 200. I know the total. Now you can put this out of 200 if you like, and that's what we don't know. We don't know that, and we're going to fill in everything else we do know. So I know the 113. I know 74 seniors athletes. I know 51 seniors on honor roll, and I'm looking for the X. Okay, so you start by adding together what you can. Now, the fact that these are all over 200, I can even clear out this fraction as well, right? I would subtract over then the 125. I would get negative 12 over 200 equals X over 200. And again, we're only looking for the numerator. So X, oops, and this should be a negative X because of here. So X is actually a positive 12. So the probability of a student being both varsity athlete and on the honor roll is 12 out of 200 seniors, or you can write it as a fraction. Are both varsity and honor roll. Okay, so this would be my solution. So we can find any piece that's missing. Just look for those keywords, right? I looked at, I saw an or up here, so I knew that was part of it. 74 was one thing, 51 was another. So I was able to keep my separate events together to find the and that I was looking for. Right. Again, we have a couple other ones who are similar to that, so I'm not going to go through them. And now we have a big problem, right? Now we're going to look at finding a probability using multiple rules. So we're actually going to look at things that are complements of each other. We're going to look at ands and ors and everything in between. Okay, so I find easiest to make a table out of the situation that's had here. So we have estimating about 8.3 people in the US have diabetes. Okay, so that's one piece of information they're telling us. They have this lab that's developed a test. It is 98% accurate for people who do have diabetes. And then it's 95% accurate for those who don't have it. Okay, so they're randomly selecting people and they want to know, well, how do we know it's correct? Whether it's you do or you don't, how do we know it's correct? So we're looking at two things. We're looking at people who do have diabetes and people who do not have it. So let's start with that table. Okay. So I have diabetes and I have without diabetes. So this could be my event A and this could be my event B if we want to look at it that way. So the first thing they tell us is 8.3% of people have it. So if 8.3% of people have diabetes, well, to find those who don't, you're going to subtract from 100. It's the complement is what we're looking at. So that leaves us with 91.7%. So this is the number of people. So 8.3 have it. 91.7 do not have it. Then we're looking at the accuracy of the results. That's the next thing. Okay, so if you are diabetic, it's 98% accurate. That's what they told me up there. If you are not diabetic, you're 95% accurate. Again, again, that's what they told me here. So I know those amounts. I'm not looking at complements for that one. So what we'll then do is find, well, what is the probability of it being accurate? So the probability of it being correct is actually taking these two values and multiplying them. Okay. And I'm going to multiply them in their decimal form. Just because it makes life easier. So I'm doing it twice. I'm doing it once for my event A and one for my event B. So the probability of it being correct in each case. And when you put those in your calculator, you're going to find that if you're diabetic, it is a 0.081 or 8.1% accurate. And if you're non-diabetic, it is 0.871 or 87.1% accurate. So to find the total accuracy, you add them together. So it comes out to being 95.2% accurate. You want to put both your accuracies, the accuracy for being diabetic along with the accuracy of being non-diabetic together. So the probability that the diagnosis is correct is 95.2%. Now, part B down here says, well, what if it's incorrect? Well, if it's incorrect, that means it's the complement of being correct. You would simply subtract that from 100. So it is 95.2% accurate, but it is 4.8% inaccurate. So in cases like this, where you are looking at two subsets, right? We're looking at diabetes and non-diabetics. And if they're looking at an accuracy point or something, anything to that effect, multiply the amount, the total amount by its accuracy or whatever they're talking about in each case, and then add them together. I know these are a little bit tricky as we go through them. So I'm going to do one more with you. Let's take a look at another one. Okay. So we have here, a company is focusing on a type of fruit drink. Okay. We have 47% male, 40% of the males and 54% of the females said they would like to buy the drink. Okay, so let's set up our table. I have group A, which is going to be males. And I have group B, which will be females. Okay, so this makes things a little bit easier for us to say, right? We have 47% males. And if we're talking about 100% of people, well, we're going to subtract those two and we get 53% are female. So those are our people. They're always complements of each other to make the total. All right, that's the total amount of people we're looking at. And then we know that 40% of the males said they'll buy it. Okay. And then we have 54% of the females are going to buy it. So just like we did before, if we're trying to figure out, well, if we randomly select someone and determine, are they going to buy it or are they not, we're going to multiply. So the probability of buying is going to be 0.47 times 0.40. That'll be for the males. So that comes out to be 0.188 or 18.8%. And then if we do the probability of buying for the female side, same thing. So 0.53 times 0.54, multiply those two together. That's going to be 0.2862, or about 28.6%. And again, to find the probability that someone randomly is going to buy it. So randomly being whether we're looking at the males or the females, we're going to add those together. And that would give us 47.4% that someone is randomly going to buy the fruit drink. And again, if I asked you, well, what's the probability of them not, you would then subtract it to find the complement. Hopefully this video of the examples helps you out.